Hello and welcome to our presentation. Today we're going to be discussing our prototyping and simulation of a robot snake.
Oh, I'm Kean Jepson.
I'm Keegan May.
And I'm Sailor Sherrod.
This is our YouTube link, and this is the link to our Google Drive folder, which will have all of our CAD models and documentation throughout this project.
This project will take the form of a series of servos and linkages fastened together. Each servo will be electrically connected in parallel to a Rev Robotics controller. All these wheels on every single snake segment, or snegment, if you will, are for asymmetric friction. They allow the entire mechanism to move forward rather easily relative to each segment, of course, but moving side to side for each segment is much more difficult. This combined with undulation of the entire mechanism allows the thing to move forward when over rough terrain. All these wide wheel arms attached to each segment are to ensure that the mechanism doesn't fall over while actuating.
So there are three main things that we're including, or three main categories of things we've been including in this project for our plan of execution. There's the mechanical parts, the electrical and computer parts, and the simulation. So for the mechanical, one of the big parts is to print the PLA linkages between the servos, which are what the servos connect to each other with in order to actually be able to move. The second one is to assemble the wheels, and these will attach to the bottom of the linkages to allow for that forward movement, as we just mentioned, but that will inhibit the side-to-side movement. And lastly, we will be assembling all the snake segments, or again, snegments, to be able to put them together to actually mimic that snake motion. Next, we'll have our electrical and computer components, which includes the servo motors, which we'll be programming using a Rev control hub. And we also want to incorporate an off button, and so that the program can be stopped without it just running on forever. Lastly, we'll have our simulation components, where we'll be importing the CAD models into Simulink to allow for that simulation. Each of the linkages will be connected to each other through Revolute joints within Simulink, which will allow us to ultimately simulate that motion between each segment. So for me, my assignments that will be done during this project. The first thing is to be programming the controller to actuate the servos properly, and this will be done using Java. We'll also be modeling the equations of motion for the electromechanical system. This includes the servo motors being attached to each other, and then the motion that they will have, or the degrees that it'll be switching to throughout the motion to mimic the motion of the snake. And lastly, I'll be adjusting the parameters of the electromechanical system to mimic these simulations through the parameter estimation system within Simulink.
I will be simulating the CAD assembly of the electromechanical system once we import the CAD model into MATLAB. I will be collecting the experimental data of the motion of this prototype and performing data analysis and graphically representing its motion.
My tasks for this project are to design a CAD model of the prototype in Fusion. I'm going to also be performing cable management on all of the wires connected to each servo to the control hub to ensure everything is connected stably and unlikely to be misplaced, plugged into the wrong port, so to speak. I'm also going to be manufacturing and assembling the working prototype, mainly using parts built on my homebrew Enter 5 3D printer.
And this is the timeline of this project. In the first part, we will be simulating. We will be designing a CAD model of the prototype, simulating this CAD model in MATLAB, and modeling the equations of motion throughout the first week. Towards the end of the first week, we'll be starting our manufacturing in the Create section, where we will be manufacturing and assembling the working prototype. We'll be performing the cable management as specified before. We will be programming the microcontroller to actuate the servos and adjusting the parameters according to the simulations. And towards the second half of the third week, we will start to demonstrate our model by collecting experimental data of its motion and perform data analysis and graphically represent its motion before.
So ultimately, our expected outcomes for this project is to one, create or construct a working snake prototype. This will include all the parts we've discussed. We want to be able to mimic the snake using a live snake to be able to document where the motion will be. We also want to mimic the motion of the robot snake within Simulink to allow for the modeling and simulation of the whole mechanism. We also want to be able to graphically represent the kinematic motion of each segment of the snake. And we also want to be able to demonstrate the model's behavior within MATLAB.
Thank you for your time, and please let us know if you have any questions.
Bye.
Bye.
Bye.